Okay, welcome back. We are going to practice paying attention to significant figures and units and how to manipulate numbers. So here we have two measurements that we are multiplying. So this is like an area, right? So centimeters times centimeters will give us centimeters squared, which means this is an area, like a sheet of paper or a piece of paper of some sort. Each of these measurements has three significant figures, and when multiplying, that's what we should get. But when you put this into the calculator, you get 143.85. Now that's five significant figures, so we're going to have to take 2 out, okay, and round up to 144, right? So the final answer is 144 centimeters squared. The next one is 6.373 times 10 to the negative 3, so we have 1, 2, 3, 4 significant figures, but we are dividing by 2. And so our final answer can only have 2 significant figures. And our units don't cancel, and therefore they will be grams per milliliter, which would be a density. Grams per milliliters are our units. When I punch this into the calculator, I get 0.00226, but I can only have 2 significant figures, so this is going to round that up, so it's going to be 0.0023 grams per milliliter. And then in order to communicate the number of significant figures more clearly, it's better to report this into scientific notation. So we move the decimal by 3, 1, 2, 3, so that we can write 2.3 times 10 to the negative 3 grams per milliliter. Now, so we have 2 significant figures. We don't have to worry about these zeros that are just placeholders, and that's really the best way to communicate and write your data. The next one is 4.7 meters times 4.7 meters divided by 12.67 seconds. Okay, so we are multiplying and dividing. We have 2 significant figures, 3 and 4. So we're going to be limited by this measurement here, which is just has 2 significant figures, so our answer can only have 2 significant figures. Our units are going to be meters times meters, which is meters squared, divided by second. That's a force. So if I put that into the calculator, I get 5.5 meters squared per second. Okay, so no problem here. The next one is a simple addition, so we have to follow simple rules. Both of those measurements go out to at least 2 behind the decimal. So that's how far out we can go with our report. So when you add these 2 numbers up together in the calculator, you get 115.995, but we can only go out to here. Now, for the units, it simply stays as grams because you're just adding. If you're adding or subtracting the same unit, you can just simply do that. But now we have to round, so this is going to round that to a 0, which will round that to a 0, which will round that to a 6. So our final answer is going to be 116.00 grams. So now we have 2 behind the decimal, right? We cannot go out to 3. Here we are subtracting. This one goes out. This one has 3 significant figures and this one has 4, but when you're subtracting, you again want to watch out how far out you're going. So you're going to the 5th place, and so we can only go to the 5th place here. So 1, 2, 3, 4, 5. Anyway, if you subtract the 2, the calculator will give you 0.003214. The units are going to be in grams, but we can only go up to the 5th one here, right? So 1, 2, 3, 4, 5. So the number is going to be 0.0032 1 grams. See, this one you round down. In order to put this into scientific notation, we have to move the decimal by 3. So we get 3.21 times 10 to the negative 3 grams. Okay, so the homework has quite a bit of practice problems. I suggest that you do them until it clicks with you, or at least work a couple. Okay, this is just a summary of what we just did, so you can see it a little better. Moving on to different kinds of numbers, right? Not everything is a measured number. Sometimes it's a counted or a defined number, like a conversion factor. Like we know that there's exactly 12 inches in 1 foot, so we don't have to worry about that 12 itself has 2 significant figures and 1 has 1. Well, in fact, it has no significant figures, or an infinite number of significant figures, if you wish, because it's an exact defined conversion factor, right? So we ignore that. We only look at the measurement and then report the result according to the original measurements, right? And a counted number is, let's say if I have 4 quarters and I know they each weigh, let's say, 4.737 grams, every single one of them. The only measurement we have here has 4 significant figures. That just means we have 4 times that, right? Like a dozen eggs, or 12 of something, or 4 of something. And so when I put this into the calculator, I get 18.948 grams. That's a total mass of 4 quarters that exactly weigh 4.737 grams. And so the answer should have 4 significant figures. 1, 2, 3, 4, or actually, since you could argue that you're adding them, so you can actually keep all of them. Okay, you can have 3 behind the decimal, so you can keep the number the way it is. But if you're just given this as a multiplication, then you need to slash 1 out, okay, and round this up. So this would then be 18.95 grams, just for the sake of sticking with the rule for multiplication. So don't overthink it too much, right? And yes, so that's 18.95 grams. Now, if you are converting, some of these conversion factors are, it's a little tricky. So some of these are exact, like there's always 100 pennies in a dollar, or 12 pieces in a dozen. But this, when you're converting from metric to English, you might run into some trouble here, right? Like 2.54 centimeters. Is that exact? We don't know. But the information is out there. We know what it is, and so you go look up or use the value that is exact. Now I don't have the one for centimeters, but I have the one for pounds. So I'll clarify this on the next problem for you. Okay. So here, if we have a question, if we're converting grams to pounds, I need a conversion factor. And so you may come across this conversion factor. 1 kilogram is equal to 2.2 pounds. Or this one here, 454 grams equals 1 pound. Okay, and so the fact of the matter is that you can actually look up this value to more significant figures if you need it to. Okay, so there are actually 453.592 grams in 1 pound, and you can probably find it even more accurately if you Google that or look in the book. Now we will use just as many significant figures as possible. So the measurement here just has 2, so we can use either one of those conversion factors. Now it's easier to use the grams to pounds, so we can just say 8.0 pounds times 454 grams divided by 1 pound equals 3,600 grams. If you actually do this in the calculator, you're going to get 3,632 grams, but we only have two significant figures, so the proper answer would be 3,600, or 3.6 times 10 to the 3 grams, because if you move that decimal to the left by 3, that's a factor of 10 to the 3. So again, this would be the better answer. Now, we can use this conversion factor, and we should get the same answer, okay? Except this is a kilogram, and a kilo is a factor of 1,000. So this actually means that there's 1,000 grams equal to 2.2 pounds. And so we can use this conversion factor, 8.0 pounds. And so you want to multiply, you want to divide into the unit. Oh, and I gotta put the grams here, right? That's really important. So you want to divide by pounds, because a pound divided by a pound equals 1. It's about eliminating and canceling units, right? When you're going from pounds to grams, you need to divide by pounds, multiply by grams. If you're going from grams to pounds, you want to do the same thing. You want to divide by grams then and multiply by pounds. You always divide by the unit that you have. And so you put this out here. Let's say you don't know. You know you have to divide by pounds, because a pound divided by a pound is 1, and it goes away. And if I'm asking you for grams, you need to multiply by grams. And then you can either use this conversion factor or you can use this conversion factor, because both of them have the gram and the pound. See? And so you just set that up. You put the 1,000 by the gram, right? That comes from the gram, and the 2.2 by the pound. So 8 times 1,000 divided by 2.2 is also, of course, 3,600 grams. And this is again something that you really want to practice. Alright, this is just nicer and neat, but the same thing I just did. And it only uses the conversion one of the conversion factors. This is another example of just conversion factors, right? 1 inch equals 2.54 centimeters. So these are all English units here to metric, and then joules is a measure of energy. We'll work with it also. And so what we're going to do is we're going to always ignore the numbers for conversion factors. When you're converting, you're going to assume what I give you or what you look up is exact. So you're never going to worry about the significant figures. So if you're converting 4.7841 centimeters to inches, see, this one has 5 significant figures. You use this conversion factor. So you multiply by 1 inch and you divide by 2.54 centimeter. You don't worry about the sig figs here, right? You report your answer as with 5, right? And so it's about canceling units, and you can do this yourself in the calculator. And if you're going the other way around, if you have 12 inches, which is 1 foot, and you want to go to centimeters, all you have to do is flip this conversion factor, right? You want to multiply by 2.54 centimeters and divide by 1 inch. It's all about canceling the unit and coming out with the unit that you're after, in this case the centimeter. So all of your exams are going to be online. You will have all of the conversion factors that you need. Let's convert within the metric system, okay? On page 7, there's table E2. This is not table E2. This is a reduced table with fewer units here. But if you are converting within the metric system, right? Like we go, well, how do you convert within the metric system? It's gram to gram, right? We use actually prefixes to indicate the magnitude of your value, right? So if we're looking at distance from here to the moon, it doesn't make a whole lot of sense to have a long number and call that meters. We use a prefix here, right? So we have megameters, for example, which is 1 million meters. So the distance to the moon may be measured in megameters or something even larger than that, which we will see. And if you have the book, you should go and open it and go to page 7 so that you see the table. Okay, I have it on the next slide. But I want to stick with this for a while here, right? So we use these prefixes, right? These are the prefixes here. Capital M is mega, is a factor of a million, right? You see here. That's, you multiply your value by a million, right? When 10 to the 6 is the same thing as a million, right? 10 to the 6 is a 1 with 6 zeros, so that's a million, right? 1, 2, 3, 4, 5, 6 zeros. K is a kilo, is a factor of 1,000, or 10 to the 3. And so what you do is, you have different base units. I mentioned the meter here, right? So you can have megameters or megaseconds. And so what that means is that let's say 1 megameter, so I use the prefix and I have my base unit here, is going to equal this multiplier here. 1 times 10 to the 6 times the base unit, okay? So this is the base unit. You multiply this times the base unit. So 1 megameter equals 10 to the 6 meters. 1 kilometer equals 10 to the 3 meters. 1 micro, which is what that little Greek sign is, 1 micrometer is 1/1,000,000th times the base unit, right? 10 to the minus 6 is 1 over 1,000,000. So 1 micrometer is equal to 10 to the minus 6 meters times the base unit. Okay, so let's go look at the table that you have. So you can get these conversion factors from this table, and you'll have access to this table, right, when you take your exam. So you should simply learn how to use it. Okay, so if I am converting, let's just make it simple. Let's just take the kilo here, right? So you find, and so these are the different base units here, right? So you can put different base units in seconds, liters, grams, meters. These are just prefixes. They just indicate the magnitude, and then and here too. Right. So let's stick with the meter for now, and let's just make that use it as a kilo, right? So the conversion factor that I get if I'm converting kilometers to meters or meters to kilometers, then you look up this factor and you say that 1 kilometer equals, and you use this, 10 to the 3 meters. Okay, so I'm going to go to the next slide just because it's blank. So if I have 1.4 kilometers, and I know I just looked up that 1 kilometer equals 10 to the 3 meters. Works the same way as centimeters to millimeters, right? You multiply by 10 to the 3 meters and you divide by 1 kilometer, because again you were canceling here, right? So then your answer is simply 1.4 times 10 to the 3 meters. Okay, so that's pretty simple. Now let's say I am converting teragrams to gigagrams. Okay, you can look at this table and derive the conversion factor by just looking at the prefixes. So if you're going from tera to giga, you're going from 10 to the 12 to 10 to the 9. Okay, what that means is that 10 to the 12 terameters divided by 10 to the 9 gigameters equals 10 to the 3. So that means that 1 terameter equals 10 to the 3 gigameters, right? And you kind of get that from looking at that table. You see there is a factor of 1,000 between these two here, right? So going from tera to giga means that 1 terameter equals 10 to the 3 gigameters. Going from giga to tera, you flip these, and so that means 1 gigameter is going to be equal to 10 to the 9 divided by 10 to the 12, which is 10 to the minus 3, right? It's the other way around. So those are the conversion factors. Now, if you don't quite make that connection when you first start doing these problems, you can do this in 2 steps, right? Because we know, and I'll go to another clean page here, right? We know from the conversion table that 1 terameter equals 10 to the 12 meters. That's a conversion factor. We also know that 1 gigameter equals 10 to the 9 meters. So if I was to convert 1.2 terameters, and I told you convert that to gigameters, you can use these 2 conversion factors, put them in a row, convert terameters to meters, and then meters to gigameters, and that's how you can do it as well if you're more comfortable with it. In fact, I encourage you to practice that because it's valuable to cancel the 1 unit at a time. So then the game plan is to divide by terameters, multiply by meters, and then in the second conversion you divide by meters and multiply by gigameters, because this is what we want in the end. And a terameter divided by a terameter is 1, and a meter divided by a meter is 1. And then all we have to do is put the prefixes in. So terameter gets 1, the meter gets 10 to the 12, the gigameter gets a 1, and the meter gets a 10 to the 9. So your number actually doesn't change. You don't worry about significant figures. You just have to worry about 10 to the 12 divided by 10 to the 9. So it's just 12 times, okay, it's 1.2 times 10, and then it's the prefix is 12 divided by 10 to the 12 divided by 10 to the 9 equals 10 to the 12 minus 9, so it's 10 to the 3, and of course this is gigameters. And you can do that with all of them, and so this is up to you now to practice that, right? So if you want, for example, if you want to go from nanometers to millimeters, you have 10 to the minus 9. You're going from 10 to the minus 9 to 10 to the minus 3. And so minus 3 minus 9 minus minus 3 is 10 to the minus 6, right? Right, so 9 plus 3, minus 9 plus 3 is 10 to the minus 6, so that means that 1 nanometer, okay, let's see if I have room, 1 nano, little n, little m, meter equals 10 to the minus 6 millimeters. Okay, you really just need to practice this table and practice some of the homework, and because this is going to be pretty important, and I really encourage you to memorize some of these because you're going to need them for other chemistry classes, especially the milli, the centi, the kilo, and the micro. And so we don't do a whole lot with these larger numbers, but we are working, and we are also going to work in the nano and pico scale sometimes, right? Nano and pico. So the smaller ones are going to be more important. It'd be good to know what they are. Alright, skipping now to examples, right? This is really just building on what I've done already. I've used the table to write the conversion factors for kilo, centi, milli, micro, nano, and picometer here. Just go to the table and I look up the prefixes. Okay, so 1 kilometer equals whatever prefix from the table times the base unit, right? So the new one here is the angstrom, okay? The angstrom was not invented, but was created because it reflects bond distances more accurately, right? So it turns out that, for example, the average bond distance between carbon and carbon is 154 picometers, which is fine. Or if you wanted to go, so we have picometers, and so if you wanted to go to something smaller, we report it as nanometers. We have 0.255 nanometers. But as you know, when we convert to scientific notation, scientists would like to have 1.54 and then have it something, right? So we could call this 1.54 times 10 to the 2 picometers, which is fine, but we don't really like this prefix either. So we'd like to have a unit, and that's where the angstrom comes in. That is, if you convert that to angstroms, we have 1.54 angstroms, right? So let me do this real quick, right? So let's say we have 154 picometers. I'll convert it, right? So I'll use this conversion factor to go to meters, times 10 to the minus 12 meters divided by 1 picometer, and then I'll put the angstrom in there, times 1 angstrom divided by 10 to the minus 10 meters, which cancels the meters, and then I get 1.54 angstroms. And so what you will see this when you see bond distances later on in some of the later chapters. Okay, so let's practice this. I suggest that you pause the video and you practice that, and when you're ready, you unpause the video and I will tell you the answer. Okay, so here's the answer. In order to convert 9.5 kilometers to megameters, you have to have two conversion factors. Let's just do the two conversion factor method. Okay, so we look that up. 1 kilometer equals 10 to the 3 meters, and 1 megameter equals 10 to the 6 meters. So then we can set this up. 9.5 km times 10 to the 3 meters divided by 1 km. I'm just using this conversion factor and I'm putting it together where I'm dividing by the unit I have. Now do this again. Now I have to divide by meters, so I put 10 to the 6 meters on the bottom and 1 megameter on top. km cancels, meters and meters cancels, and my answer is in megameters, which is fantastic. Number doesn't change. It's still 9.5, but we have a factor times 10 to the minus 3. So it's just 3 minus 6 is minus 3. That's how that works, right? So 10 to the 3 divided by 10 to the 6 is simply 10 to the 3 minus 6. You just work with the prefixes, but that's basic algebra. Okay, so here we go. We have convert 0.013 nanograms to centigrams. Recognizing the prefixes, find them on the table is important. 1 nanogram is equal to 10 to the minus 9 grams, and 1 centigram is equal to 10 to the minus 2 grams. I'm also going to convert this to scientific notation, so I'm going to go 1.30. We have this 0 is significant, so we have 3 significant figures, times 10. So I moved it over to the right by 2. This is 10 to the minus 2 nanograms, and then I'm going to do my double conversion. First I go from nanograms, so 10 to the minus 9 grams divided by 1 nanogram. So my nanogram nicely cancels, and then I go to centi. So I put the 1 centigram on top and 10 to the minus 2 grams on the bottom. The 1.30 doesn't change. My units are going to be in centigrams, but it's going to be times 10 to the something, right? So we have 10 to the minus 2. I'll just circle it. 10 to the minus 2 times 10 to the minus 9. So you add these, that's 10 to the minus 11. And then you subtract the 10 to the minus 1. And so you end up with 10 to the minus 9, right? Because if you're minus 2 is plus 2. So you get 10 to the minus 9 centigrams. Okay, so let me just finish the metric to metric. These are just additional base units, right? We just did an example with grams. And so you should know by now how to use the table to derive these conversion factor. For example, the milligram here, 10 to the minus 3 grams equals 1 milligram. Now, if you want, you don't have to. You can just stick with this. You can convert it and make it look a little nicer, right? So this is just changing the 10 to the minus 3, okay? So you're just gonna do a little bit of algebra. You divide by 10 to the minus 3 both sides, right? So if you have 10 to the minus 3 grams and you divide by 10 to the minus 3 and then 10 to the minus 3, that's what this is here, right? Because this will go away, it'll be 1 gram, and 10 to the minus 3 means we have 10 to the 0 plus 10 to the 3, so that's 10 to the 3. I don't know if you caught on to that, but that's pretty easy, right? Just like 100 centimeters equals a meter instead of 1 centimeter equals 10 to the minus 2 meters is a lot easier to deal with. Okay. Seconds is going to be the last one, and then we'll take a break. Well, you can keep going and going, right? It's summer, so you should be having 2.5 hours of lectures. Okay, so seconds also is another SI unit that you can use with prefixes, microseconds and nanoseconds for something very, very small, something that happens very fast, speed of sound and things like that. Yeah. But if you have something larger, we don't really use megaseconds or gigaseconds. You know, if you had, you know, let's say 75,462,975 seconds, and I told you that's really easy, right? It's 75 million, so it's 75 megaseconds. That doesn't tell you anything. Is that months? Is that years? Is that 10 years? Is it a century? So it makes more sense to convert that differently, right? And so time is really something that we haven't turned into a metric system. We can use the prefixes, but we still use 24 hours and 365 days in the year and so on and so forth. So you can convert that to something that makes more sense. So 1 minute is 60 seconds. 1 hour is 60 minutes. 1 day is 24 hours. And these are conversion factors that you know, that you're familiar with, right? And then 1 year, we're going to use and take the leap year into consideration, is 364.25 days, right? Seconds cancels, minutes cancels, hours cancel, days cancel, and we get 2.3978423 years. Well, it's 2.4 years, right? And if you wanted to convert that to something more reasonable, you take the 0.3978 and you convert it to days, And when you get that, you get 144.9 days. So we have 2 years. And I'm going to round that up, 145 days. And that makes a heck of a lot more sense than saying 75 megaseconds. All right, 2 years, 145 days. So make it a reasonable answer. All right, time to take a break. If you have energy, watch lecture 3.